Okay, let's get started. Thank you all for joining for this CIIR talk. It's my pleasure to introduce Suzan Verberne. She's a professor of natural language processing at Leiden Institute of Advanced Computer Science from Leiden University. She doesn't really need any introduction. She has been an active researcher in NLP and IR, providing a lot of leading service roles in our community. Most recently was as a PC chair of the CIIR 2025. And she received her PhD from Radboud University in Nijmegen and in the Netherlands in 2010 on the topics related to question answering. And since then, she's been involved in a lot of NLP/IR projects, mostly around information access on particular domains, from health to even archaeology, legal domain, and so on and so forth. Most recently, she works on interactive information access systems and basically how search engines and large language models interact or interplay. So without further ado, please join me in welcoming Suzan to UMass virtually for this talk.
Thank you, Hamed, for introducing me. Thank you for having me. And actually, this is my first slide introducing myself, but you have actually said most of this. This was the cover of my PhD thesis that was about question answering for why questions. And so one thing you may notice is that I was a postdoc for quite a long time. I would like to say I was a happy postdoc for quite a long time. So that really gave me the opportunity to work on lots of different projects, get some experience with chairing, with teaching, etc. I also had 2 kids in that period. So after that, I became an assistant professor and I grew into a full professorship since last year. And as Hamed has introduced, I do a lot of service work for both the ACL and IR communities. So that's where most people know me from, I guess. But today I'm talking about my research. And this is what I would like to present. So, well, 2 already heads up. One is there will be some work from you, Hamed, and Ali Reza also referred here in this talk. And the other heads up is that some of these results were obtained this week. So that is very new and, of course, first time I present them, but still lots of questions about those results. So we're going to talk about maybe a little bit of a cynical question. It has the age of search engines as we know them ended. And then mainly talking about the interconnection between LLMs and search, I would say in a positive way. So I'm both not a person who says, well, search engines and retrieval will never be relevant again, but I'm also not a person who is saying LLMs are the devil and we should never trust them, right? So I hope I can bring some positive synergy to the relation between them. And how I know your group is that you also very much work on this area that has both retrieval and generative AI. Good. So let's start with this first item here. Has the age of search engines as we know them ended? So the reason I ask this is because of this paper. So normally I'm always like talking with the room in the sense of like, who knows this paper? But you're really small on my screen, and also for the YouTube recording that doesn't really work. So normally I would ask you, maybe please raise your hand. But here, maybe some of you have seen this paper. Can long context language models subsume retrieval, RAG, SQL, and more from last year? And what they propose in this paper, I don't know the authors personally, right? I just know the paper. What they propose in the paper is actually to put the whole index or like all the documents from the index in the context of the LLM. So there will be some instruction, then the collection, and then some few shots examples, and then the question, the query, and it will return something from the context. And so what they show is that it's rather impressive in the sense that they have a number of LLMs, And then they have all these test collections. So they do it for other tasks as well, but these are the retrieval collections, so you will recognize most of them. And what they call specialized here in the rightmost column, that's actually just the benchmark result for a supervised ranker, right? So the thing we regularly do. And so they say, look, there are actually quite some benchmarks where Gemini is better than a fine-tuned, well, cross-encoder or whatever it is, right? So that is very impressive. And I think there's definitely some promise in this. But my main point here to make is that retrieval is so much more than indexing. Like search is so much more than indexing and retrieval. So the part that is replaced here is the indexing, right? And the way to get stuff from the index. But I think, and that's one of the reasons I like the IR field, even though my background is in NLP. I mean, IR is so much broader. You first need to find out, okay, which collection are we going to ask this query to? You still need to provide a ranking, right? So that's not explained here. But also, there are so many different tasks and so many different users. We still need to distinguish between navigational and exploratory tasks, for example. We still need to find a solution if documents are longer than the MS Marco passage collection. We still need diversification to help users with ambiguous queries. We still need some forms of transparency, like we are used to them in snippets. And we still need evaluation. So all in all, I would say there is so much going on in information retrieval, in search, that involves things other than putting stuff in a long context language model. That in my view, even if you change paradigms, and I think there's many promising paradigms now along the horizon, there's still so much of what we do in IR that is still going to be needed in the future. And lots of that is related to the user. Right, so having said that, I would like to now present the takeaways of the talk before I get into the details, because this is what I argue we should focus on in our work. We should go beyond English. So there's still a lot of the benchmarking and a lot of the training data is in English. We should go beyond benchmarks. Some good work on that. Like, can we expand the type of problems we work on? Going beyond accuracy, well, and MAP, precision at 5, etc. Multiple perspectives of evaluation. I get to that. Find topics that go beyond models, in the sense, like, we can assume that next year, the year after that, we have better LLMs, right? So what are the topics that are still relevant at that point? So what would be the CIIR 2025 paper that will win the Test of Time award in 10 years, right? It will probably be something that is model agnostic, something like related to evaluation, for example. I don't know, but so what can we do beyond models? And of course, well, we all know as researchers, beyond GPT-4, beyond ChatGPT, for example, can we make much smaller models and still achieve the same results? So this is, and I get back to this at the end, because all of this comes back in this presentation. Okay, so let's continue with the question of how LLMs can facilitate search. And well, these weeks I'm also lecturing IR, and last week I gave my lecture about conversational search. It has been there a couple of years, and I have the Zamani 2022 book there that where I have some images from, but that book was just preceding the release of ChatGPT, if I remember correctly. But still, it's very valuable. So conversational search, well, nowadays it looks like like this, right? So this is the DuckDuckGo interface to GPT-4o. What happens in the Netherlands on April 27? Well, we have a national holiday this weekend coming up. And I get a reply, right? So I ask a question in natural language, I get an answer in natural language, and we all know this is incredibly fluent, etc. So what we did this week, and here comes the work that is brand new. One of my PhD students actually set up a user study on Prolific to find out why people prefer ChatGPT over Google or vice versa, and how that relates to user trust. So to what extent do users trust ChatGPT in providing information, specifically for search? So he explicitly said it's not for writing help or coding help or whatever, really for search. And so what he found was that there are two main groups of users. There are daily users of both ChatGPT and Google, and there are daily users of only Google. And the group of both is larger than the group of only Google. So you don't compare the red and blue bars here. This is just about comparing the categories. So on the left is what design aspects of ChatGPT do you like better than Google? Strangely, the top answer, speed and responsiveness. I mean, ChatGPT is incredibly slow if you compare it to Google. So this has to do with the fact that people want the engine to answer complex questions for them, and then for the task as a whole, they get an answer faster. So that's interesting. But then interaction flow, but also absence of ads, right? I mean, I hadn't realized that actually, to be honest, but that actually is also a factor playing a role. And there's some more. But then if you look at the other way, like what design aspects of Google do you like better compared to ChatGPT? Well, mobile usability, simplicity, also the speed again. Right, so it's interesting to figure out, and I come back to this later in this presentation, and like to what extent are users willing to trade off the possibility that there is incorrect information in the output for having really nice interactions. And well, spoiler alert, people are willing to trade off, to make that trade-off, and they do realize there can be inconsistencies in the output. So this is submitted to a workshop at CIIR. So hopefully in the summer we will be able to present this. Right. So yeah, why do people like LLMs for search? Because it answers complex questions and it helps synthesizing information. But yeah, it also has problems, and people become more and more aware. Like, 2 years ago, I would give presentations where I would make people aware of hallucination. But of course, everyone is aware of that now, at least like regular users of ChatGPT. So Hamid Zamani is apparently also a singer-songwriter. Hamid, you probably know. I didn't know that. But I mean, strangely, it didn't ask me to disambiguate, but it went for the highest frequency entry. But luckily, it has conversational ability, so I can follow up. I meant another Hamid Samani, right? And then it comes down with a correct, I guess, correct or largely correct biography. So what I also did. Oh wait, let's first show me this. So I can see it's wrong, and I specify my request. So as long as you are knowledgeable of the topic, you can do this very well. But then if you think about it, maybe for some of these things we don't want LLMs, but we can use web search, right? If I use web search, I get the diversification. The ambiguity of the query is immediately clear from the interface, right? So I get both results, and it even explicitly shows me query suggestions for the two meanings. So yeah, this is, I would say, for this case, this is more helpful. So one thing that I have been doing to test the factuality of ChatGPT in the past few years is ask it to write a biography of myself, not because I'm so fond of myself, but because it's very easy to check the information, right? You know your own biography. And right now, I can happily say it became correct, right? So ChatGPT now writes me a correct biography. And 5 months ago, the same request would give me completely wrong information, right? So it was plausible, but not correct. And I tended also to use this as an example how probabilistic generation of tokens leads to information that is plausible and believable, but not necessarily correct. So in the category, it could have been true, right? And it's difficult to verify this if the sources are not known, but in fact, it's the sources that made the difference in the current version of ChatGPT, because ChatGPT now has RAG. If you go to the DuckDuckGo interface to GPT-4, it does not use RAG, and that gives it, like, generates a lot of wrong information. But in the interface of OpenAI itself, it has sources, and that made the difference here. And this is actually nice because from the very beginning, when I gave presentations also to mainly actually to non-experts, so for example, I would give a presentation to medical doctors and I would warn them for hallucination. And I always tell them, like, this message, as long as the source is not shown, it's difficult to verify the correctness of the information. And that is always how I start to tell the story of how important information retrieval is, because you have sources. Right. So yeah, that is the topic I would like to get into now, and that is the role of sources in generative conversational search. So again, without sources, it's difficult to verify the information provided by an LLM. So here's, if you ask a question with a wrong premise in it, when did Einstein visit Rotterdam? I like this example because I work in Leiden, and Einstein worked in Leiden for a while, so he's a famous person in my university, but he never visited Rotterdam as far as I know. So you can ask a question that has a wrong premise because it says when, but it didn't even happen. Actually, Llama is kind of honest. I couldn't find any more specific information about the exact dates of the visit, okay? Well, checking the web search engine, it's pretty clear that this never happened, right? So this is, I would say, before ChatGPT used RAG, it's pretty worrying that it's not warning you when your premise is wrong. And this remains to be a problem until now. So even with RAG, it can be still fooled by questions with wrong premises, which means that if you have not the right expertise about a topic, you can be fooled quite easily. And it's also something I warn my students about. So actually the importance of sources is something, of course, that developers of generative models realized, and that is where RAG, retrieval augmented generation, came around. You are all familiar with this. All of the audience here at this point knows what RAG is. First retrieving relevant documents, adding them to the prompt together with the question, and then providing the answer. And RAG actually helps a lot in reducing hallucination, right? Like in this example that I gave about myself, and it made the big difference. But it cannot fully prevent hallucination. So this was a famous example from a while ago where Google got some bad press because it was providing generative answers to questions, but whenever these questions had, again, a wrong premise, it would make up something. And this happened, maybe you remember this. At that point, when this happened, I actually thought it was not so funny, in the sense that at least Google was showing the sources here, right? So at least you can check for yourself. And at this point, ChatGPT did not do any RAG yet. So yeah, people were saying, oh, Google is also trying something and it immediately goes wrong. Well, yeah, but at least with sources. But this week I also saw, I think on Reddit, did I see it on Reddit? Yeah, there was this, people mentioned that it's also nice, you can make up something that sounds like a saying and then say meaning behind it, and Google will make up a definition of your made up saying. So that's something you can try, right? So this shows again that if you have generative models, it will generate something. It will always generate something. And one of the things that plays a role here is that these models were very much optimized to help people, right? To be friendly, and to be helpful. And yeah, this was all like in learning from human feedback. This was a very important aspect, that the model was friendly. So that means that if you are in a conversation with ChatGPT and you ask it, "Are you sure?" it's going to double check and then say, "Oh, I stand corrected," right? So yeah, it's challenging for people who are doing these optimizations and to make this trade-off between, always being friendly and correcting the human when needed. So RAG actually can help quite some situations. So when information is more recent than the pre-training date of the LLM. So if I was checking, if I now ask Mistral, who's the president of the United States, it's saying Joe Biden. But then it says, but I may be mistaken because my pre-training date is 2021. Okay. So RAG can help by like first getting some recent information before the answer is generated. But it can also be very helpful for specific collections, like for company-owned collections, for example, or even for personal collections, personal information. So here, an example of maybe the worst chatbot that I've ever met, the chatbot of KLM, the airline. The thing is, companies want to be very, very sure that their chatbots are not making up something that is not real. For example, making up that I can get a refund of my delayed flight. But so to prevent that, they make this like completely controlled setting where I have to say A for yes and B for no instead of answering yes or no, right? So please connect me to a human. If I understand correctly, you would like to speak to a service agent. A, yes, B, no. And this is a reason, right? So they want the controllability to be very, very high. And this is a context where like RAG can be very useful because it can prevent that information is given that does not come from company information from company sources. So we don't collaborate with KLM, but we do collaborate with other Dutch companies, large retailers, etc., and insurance companies and telecommunication companies to see how we can make their chatbots both fluent and trustworthy. So another thing in that context is that people, when they continue talking to a chatbot, so some of these chatbots have a WhatsApp interface like this one, they expect a chatbot to have knowledge of their history, like to have personalized interaction. And so this brings me to the use of RAG for personalization. And so here, your work, Hamed Alireza, comes in about LAMP, when language models meet personalization. So when this benchmark came out, we thought, hey, this is nice. Here is a data set where we can actually test our use cases for RAG based on information of which we are sure is not in the pre-training data. So here is an example of one of the tasks inside LAMP. This is about creating personalized titles. So there is a collection given of abstracts and titles of certain users, and then we get a new abstract and we're generating a title for that same user, so with the style of the user. And we did some experiments with this, and one of the analyses that we wanted to do, because we work on a project about efficiency and data efficiency, computer efficiency, working on smaller models. So we tried if we could get results on LAMP that have equally good results, but with much smaller models. So here we worked with a quantized version, so 4-integer version of OpenChat, compared it to the full floating point version, and well, Flanty5 and ChatGPT. ChatGPT, of course, we don't know much about, but here you see like the virtual RAM that is needed for this quantized version is really much smaller than of these models. And the VRAM, the virtual RAM, is the bottleneck, at least in my context and the companies we work with, for using larger models. So yeah, we found that it was possible in these tasks, so this is task 3 and task 5, to actually get competitive results with the small model, which I think is very interesting and useful results. I mean, this is just one example, and later we replicated that on other tasks as well. And maybe you also have this experience that with much smaller models, sometimes you can get competitive results. And sometimes it only does require that you put some more effort in it, right? So, for example, with a smaller Llama model, you need to add few shot examples compared to larger Llama model that can do it in 0 shot. But I think it's worth it to, make the models accessible to more environments, and to also spend less energy. Right, so this is one example of the possibilities of RAG. And so, yeah, all in all, my view on this is that there is still a lot to do on RAG in research sense. So companies are using it now for many, many different things. It's incredibly popular, but to be honest, there's still a lot of work to do. And to be even more honest, the retrieval part needs a lot of work. So there is some work, luckily nowadays, on like jointly optimizing the retrieval and the generation, because it appears that LLMs cannot deal with retrieval results as well as humans can, and that in some cases we have seen that retrieval is even the bottleneck in giving the correct reply. I'm interested to hear later from you if you have the same experiences. But it definitely has advantages like connecting to a source and thereby giving some transparency about where the information comes from, retrieval from proprietary database, so company information, newer information, updating the retrieval index without updating the LLM, and adaptation to a new domain or even personalizing. I think this is all very useful and promising. But then again, hallucination can still happen. See the example of the how many rocks should I eat per day? And well, retrieval, it has to be really good on like a very low value of K, right? So typically we use like K is 5 for the top 5 retrieved documents in RAG, but that's not a lot. So you have to have the right information there. Good. So I would like to move on from this, still continuing with RAG, partly, but to focus a bit more on search tasks in critical domains. So Hamed has already introduced that I did a lot of work and still do on domain-specific IR and NLP. And one of the reasons that interests me, well, actually 2 reasons. One is it's challenging. So there are challenges that you don't come across in benchmark sets. And what I like the most is when a domain-specific problem forces you to solve something that is then also applicable in other domains or the general domain. So, for example, working in the legal domain has forced us to come up with solutions for aggregating information from long documents. And then actually on the web, that's also useful because many documents on the web are much longer than the documents in the MS Marco passage collection. So I like working on difficult domains, and often with master students, they do an internship in a company, and that brings an interesting challenge to the table where the master student then has to find a solution. And this was one of the examples. This is also one where RAG plays a role. So this was to do RAG for legal question answering. And in this case, attributed question answering. So attributed question answering is not only answering the question, but also showing the source of the answer. So we add a reference in the answer indicating in which document the information is provided. And this was to ask questions about certain conditions in the law. So these are things like, when can the court terminate the guardianship of a natural person? So questions that have to do with conditions that have to take place before something is possible in the law system. And this was for Dutch. And so in case you wonder, this model has a Dutch name, Geitje. It means little goat. And it's a Llama version that was further trained for Dutch, the 7B model. So we worked with that, and the students implemented RAG and generation with several models. One of them was Geitje. And let me show you the results, because I actually think this is interesting. These were the retrievers that we had. So here we come back to the non-English aspect. When working with term-based models, it doesn't matter what the language is, right? But when working with embedders, of course, it matters what the pre-training language was. Well, there is an expert model for Dutch, but for E5, for example, which is a very effective retriever, we have a multilingual model, but we don't have a Dutch model. So the choices are not that big if you move outside of English. And we also compared a couple of LLMs here, also GPT-4o, but Geitje, and then Llama itself. So first of all, for the retrievers, E5 multilingual model was very effective. So hit S3 means that 87% of the questions had at least one relevant answer in the top 3. Now, if we move on to the generation results, so this is Meteor and Rouge, but also the citation precision and citation recall. So this is the attribution, like how many of the document references are correct. And then, first of all, what you see is how much better GPT-4o is than the other two models, where Llama also is better than Geitje here on this aspect, but also here on the citations. This difference is huge. So that was a bit disappointing for me, because I always encourage my students to work with more open models than GPT-4. But another thing I wanted to point out is if you compare this like success of the retrieval with like what we get here in terms of precision and recall of the actual attributions that are shown in the answer, we lose a lot of quality in the attribution step. And this comes back to the point that I had a few slides ago, that we may have a pretty effective retrieval system, in this case 87% hit rate, but the LLM is not necessarily capable of handling that completely correctly. So I think there is an interesting gap here, and it's not unique to this task. This is just one domain-specific task where we saw this happening. So I think there is still a lot to gain here to make sure that we not only have good retrieval and not only generate fluent answers, but that the connection between the two is very good. Otherwise, it's not so helpful, right? With a citation precision of 69%, I mean, more than 30% of the citations that the model gives are just not correct. for a critical domain, that's not enough, I would say. Another domain that I would like to call critical is, to get back to that KLM example, commercial context. So service chatbots, again, companies want to be sure that the chatbot is not promising anything that is not correct. And this is a project that we have ongoing there. It's called Lesson. It's a joint project also with the University of Amsterdam, Nijmegen, and Groningen. And it includes researchers not only in NLP and IR, but also, for example, in privacy and security, and also there are aspects related to transparency, bias, etc. So it's a very broad project about conversational agents. And so the companies in this project, they are really interested in using LLM technology. So you have to realize, and maybe you have this experience when you try to communicate with a company chatbot, once you're used to how good ChatGPT is, you get really annoyed by these chatbots. Because they often don't understand what you want, and they have a very limited like vocabulary of answers where they keep referring you to the same thing. And that has a reason, right? So this all has to do with the guardrails that these companies implement for safety, and to prevent hallucination. So one of the things that we do in this project is that we find ways to make the chatbots better without losing these guardrails. And so one of the things that the companies want is actually classic intent classification. So user comes with a request like, please connect me to a human, and the model is just classifying that in a set of predefined categories and then giving a reply fitting that category. So this was EMNLP paper of last year. No, sorry, EMNLP on NACL. I think NACL. Sorry, you can find it. You can find it all. Where we actually were trying to do this for domains where we had almost no data. And so the idea that we had here is this is pretty standard data augmentation with LLMs. So give me a few utterances with this label. It will do that. But then what we did is we had a model that we fine-tuned on translating the generated utterance to realistic user utterances. And the interesting thing is this model was fine-tuned on a domain where we did have data. So this is a setting where a company for some domains already has training data, but for new domains does not have. So that's also why it's zero shot. For the target domain, we don't have any example data. And this refiner was very effective. So this is, for example, what it looks like. So this was for the banking domain. And the real data would be something like, please freeze my account. But what Llama 3 is saying is, I want to freeze my account to prevent any unauthorized transactions, right? So it's very like, fully grammatical, completely well-phrased sentences, like how LLMs talk, I would say. And then what the refiner does, turns it into put my account on hold for now, right? Without any capitalization or whatever, which is much more realistic. And so we show that if we like the utterances, so these were generated for domains, like we did not have any training data for bank. The refiner was fine-tuned on other domains, but it can make that translation from like the fancy LLM language to real human language. And then we fine-tuned an intent classifier, we trained intent classifier, and it was much better than the other like zero-shot generated data. So I think this is an example where we can use the power of LLMs, but also respect the wishes of industry to stay very close to the safeguard, right? So yet one other example along these lines maybe is to use LLMs to generate some explanation to the user about how their query was interpreted. So queries, as you know, you're all IR people, queries are typically short and underspecified in normal web search. And when a user is working in exploratory search, they want to revise their query to improve them. So what we did in this paper is actually show to the user, so here's a query. Query is only free on 12. So we got some retrieved documents from the search engine, and then the model is translating to the user, okay, based on the documents that we found, this is how we thought we should understand your query. So this is what we think is relevant to your query. And the user can now see, no, but wait, this is not at all what I wanted about free on 12. I actually had some very different aspect in mind, and then rephrase it. So this is how you can use like LLMs to provide feedback to users without actually have the LLM replacing the search engine. So that brings me to the last part of this lecture, and that is the role of the user. So in the very beginning, I already introduced that you can change the indexing process, and there are good paradigms of doing that, and maybe we will get there in the near future. But the unique thing about IR is that there is such a big role of the user, because search engines are by definition human in the loop. The user defines how the query is formulated, which query suggestions he accepts or not, where he will click, etc. So all these aspects are part of the evaluation, and well, you may not have realized, but any metric that we use, in fact, is a user model. If we measure precision at 10, we make a lot of assumptions, and that the user looks at the whole top 10. The user doesn't care about the ranking inside the top 10. The user doesn't look beyond the top 10. The user doesn't care about recall, right? So every metric has a user model in it. And that is, I think, implicitly, that's the reason why we always have so many metrics in IR papers, because we kind of want to make sure that we take all possible user types into account when we evaluate our models. But one of the things that is very important, and it's good that there's quite some work nowadays on that, is that we look at other aspects than just ranking effectiveness. So one of my other students, you may have met him in conferences, he is finishing his PhD, and he did some good work on bias, analyzing bias. So this is one of those topics where I say that's model agnostic, right? This will remain to be relevant. So this is one of the things that he worked on, is how can we properly measure bias in a ranked list based on like the content of the results? So for example, here is the query is famous footballers, which is gender neutral, but still all the results are male, right? And maybe that's what the user wants. So we cannot know what the user wants, but we should have a way to measure this, so how heavy this bias is in the results. And then we can compare search engines for that. Another interesting paper, this is a bit more recent, is that this is again about attributions, like attributing sources in RAG. And what he investigated is, if we have explicit information about if the author of a document was either human or AI, so we had this like true information and counterfactual labeling, does it have an effect on what the LLM is referring to, and like what the attribution is? In other words, is the metadata relevant to the LLM? And the answer is, in fact, yes. So LLMs tend to cite more documents that are explicitly labeled as this was written by a human. And so Amin extended that to also other types of metadata, and he made a small Python package to test it also with, for example, regional information or the types of bias. So I think there is some interesting stuff there. to continue working on, especially because RAG is so everywhere nowadays. So yeah, why do we need these multiple forms of evaluation? So ranking is only one thing. There's another example here of a project that I did with a master's student, and this master's student also did an internship at a recruitment company called Randstad, and this was about a course recommender system, and behind the recommender system was a ranker, and there was an in-production ranker based on BM25. And the student did quite good work, data labeling, etc., trained a better ranker, and added summarization and everything, two-stage instead of simple. And on the benchmark sets that he created at the company, this ranker was way better, right? So this is such a large margin. So even on a small test set, this is substantial. And so the company was happy and said, well, we want to do an A/B test. So they set up an A/B test in the US and Australia, and ran that for a while, and then collected the interactions to see where do people click through. And it appeared that actually the production system, BM25, gained more interactions from users than the more complex ranker, the T5-based plus summarization. And that difference was actually rather substantial. Usually what you see here is this is where they go from top to bottom, right? This is where they enter, and then they click the snippet open, and then they go to the actual document. That is the equivalent for in information retrieval. So the company was a bit puzzled, and the student as well. It's like, why do users prefer the BM25 results, or at least seem to prefer? And we dived into that, and it may have been something to do with speed, but then again, the student made sure that the complex ranker was fast enough to show everything before the whole page was loaded, something like that. So that we are not sure. But the other thing is transparency, actually. In term-based rankers on BM25, the user can immediately see that the terms that they searched for are in the snippet of the course that they were looking for. And the T5-based ranker actually had semantic similarity, of course, embeddings-based, and therefore matched a lot of non-literal words like abbreviations to full terms and synonyms to, and that may have caused the users to look over the relevance of these documents, even though they were relevant. So that was actually an interesting finding, and what I in the end advised to the company was, well, maybe you should use the T5, but use it at index time. Expand documents at index time. So this is the strategy of Nogueira and Lin, the doc T5 query approach, where you get the strength of the embeddings-based model for the semantic matching, but you have all the speed and transparency of BM25 at query time. So yeah. An example that shows you do need multiple forms of evaluation. Okay, so now to conclude, let's get back to these things that we did very recently. So here is the question: what are the reasons you would prefer ChatGPT over Google for search? And yeah, it clearly shows that things like it provides more personalized and tailored responses, exactly the kind of stuff that we as IR researchers have said about conversational IR, right? We said like decades ago, we said, this is what people want. Well, it seems to be the case that if it works well, people do want that. Easier to use, gives me clearer answer, feel more engaged and understood. That is also interesting. Feels more human-like. So that was actually something that my student followed up with. And he had this statement, he had a few other of these type of statements, but this one was the most interesting. I would prefer ChatGPT over Google for information search because it feels more human-like and personal, even if it sometimes provides incorrect or misleading information. And if you look at like the blue ones are people who use both Google and ChatGPT, how many people agree with that statement, right? So people saying, yeah, I actually do prefer ChatGPT for information search if it's more human-like and more personal. And it's fine if sometimes the information is incorrect. Yeah, so I guess people trust on their own estimation of how correct information is and to recognize incorrect information. So I think this is food for thought and we should follow up. So yeah, to answer the question from the title, is a search engine of the future a chatbot? Yes, probably. But I would argue that IR perspectives and everything that the IR field has been doing forever is still very relevant. Everything related to users, things related to transparency, to evaluation. So I think there is still a lot to do. And therefore, I would like to repeat this slide with what I think we should focus on now. And that brings me to the end. Thank you.
Thank you so much. Thanks for the interesting talk. And I think we have time for a few questions. Any questions from the audience or folks in online can also unmute themselves and ask.
Thank you, Suzanne. It was a nice talk. Thought-provoking. I have a small question about the example where you were having the large language models say how the query was interpreted.
Mm-hmm.
And because what you were doing was asking it, you were looking at the answers, the top-ranked documents, right, and then having it provide this interpretation. It's not really a statement of how the query was interpreted. It's really a summary of the documents. Is that right? So how is it different, except maybe in the length of it, than a summary of the top-ranked documents?
Yeah, that's interesting because that's actually the baselines we also compare to multi-document summarization. I think it is very similar, but it serves a different purpose. So in a way, the search engine summarizes the top-ranked documents, thereby indicating why these documents were considered relevant to the query. So there is some contrastive learning here that distinguishes between the documents that the search engine ranked very high because it thought it's relevant, and documents that were ranked very low, and thereby the search engine thought were not very relevant. And this gives information to the user about what was considered relevant and what was not.
It reminds me of the explanation work where it's a post hoc explanation of what a system did by, picking words that have high weights or something like that. But it's a fluent response, but it seems very similar to that rather than something that actually explains what the search engine did. If that should make sense.
It is very similar to that. And it's also that line of work indeed. Yeah.
Thank you.
Any other questions? So I would ask one question about, I found this a study between the ChatGPT versus Google search comparison interesting. And that reminds me also another study from folks at the University of North Carolina who also did a similar study, ChatGPT versus Google, but with a focus on different queries and query types. Like, for example, for what query types people prefer Google, for what query types people prefer the ChatGPT-like system or the large language model. So I was wondering how would the different questions would impact people's preference over when they prefer ChatGPT or Google? Is that any? I was wondering if you have else to share about that.
Yeah, I'm pretty sure that is core to this whole distinction, because I think it will become more and more clear for what type of queries you can better ask Google and for what type of queries you can better ask ChatGPT. And I think that there are many people, and that's actually what this study shows, that know that pretty well because they use both and they see benefits of both. So yeah, I think complex queries, the more complex the query, the less useful Google is to you unless you're willing to do many different searches in a row, right?
Yeah, I can imagine that. If the ChatGPT does the right thing. But
Yeah, but that's so yeah, indeed. And yeah, I use it as well for some stuff and sometimes, and I probably you all in the room have the same experience, that sometimes it surprises you for how good it is. And sometimes it surprises you for how bad it is at a task, right? So it remains a bit unpredictable how well it will be at some task.
yeah, absolutely. Okay, thank you so much. Really enjoyed the talk. Let's thank Suzanne one last time.
Thank you.
So yeah, that's the end of the talk. We will join the other Zoom links for the meetings in a couple of minutes. We need some time to go upstairs in our offices.
Okay, see you in the other Zoom link.
So.